Let's talk about printf for a few minutes here, shall we? Printf is short for print formatted, and we've already used it a few times, and now we're going to find out what all those interesting little percent characters are in the format string that we've been using. Printf takes in a string, which is called the format, and then it needs as many variables to fill in the data in the format string as the format requests. So let's look down here. Here's printf, and there's a double quotes, and there's a double quote. So that's the beginning of our string. Now this string could have been defined someplace else in our program, and it can even be dynamic. You can create this thing as you go through your code. It's just a string, like any other string in C. So this string, or a pointer to a string, gets passed into printf. Then a comma operator, and then we have to have variables, or in this case another string constant. We have to have enough of these to satisfy the replacement characters, the conversion specifications is what they're called, over here. So here we have 3 percents. We have a %C, which is a character, and so we'll pass in a character that we've defined earlier, a C. Here we have a %D, which is going to be a decimal, and that's just an integer I that was created someplace up in our program. And here we have a %S, and that's for a string. And then our old escape sequence we talked about a long time ago, this one is our new line escape sequence. And here, since we have a %S, we need to have a string pointer. Now these have to be in the very same order as they're used over here in the format string. It's 1 for 1, and it's undefined what happens if you don't have enough of these items to match up 1 for 1. It's undefined what the compiler is going to do because it's going to go looking for things that aren't there. So that's a bad thing. If you pass too many items, it doesn't really matter because printf won't see the other ones that are out here on the end. It will pass them into printf, but it won't use them because it uses them in order, and it would ignore anything out here on the end. Here's some of the, or actually all of the conversion specs are coming up in a table, but this is how a conversion specification is built. First of all, you have the percent. The next thing that you may have after the percent, if you want to, and if you are going to use the dash, it has to be right here after the percent. That means left justified. If you have the percent like down here, 3.3s, we'll see what that means in a minute. If we were going to left justify that string into its field, there'd have to be the dash right here, the hyphen, to mean left justified. It has to come right after the percent. Now, that's fine if you used it or if you didn't. Either way, the next character that could be here is a number. And I just have the little hash mark here to show you that this would be a number, 0 through 9, and actually even a larger number than that, because this is a total field width. This is how wide the field will be that this item over here will be printed in. So the first number is the total field width. Then if there's another one, there will be a dot between them. We'll have a dot, and then the precision. Now the precision means different things to different kinds of variables being passed in here, different kinds of values. If it's on a %S, then that's the maximum characters of a string to be printed. So here we have %3.3s. So what I'm saying there is that in a field 3 characters wide, you can put a string of up to 3 characters long. So if you made this, say, 10.3, you'd have a field 10 characters wide, and the last 3 of them would be the first 3 characters of the string that was passed in. If you did a %-10.3s, that would give you a field 10 characters wide using the first 3 characters of a string, but it would shove them over to the left side. They would be left justified because of the dash. So the precision in a string says the maximum characters of the string to be printed. Now, if this is for a float, an F in here, like here, %7.2 float, this says that there will be 2 numbers, like currency, 2 numbers to the right of the decimal point of the floating point value will be printed. So here %7.2 means in a field 7 wide, you may put 2 digits to the right of the decimal. Now that doesn't mean 7.2. You're not going to have 7 and then a decimal point and then 2. You're going to have 7 total, which will mean 4 valid characters, a decimal point, and then 2 to the right of the decimal, okay? Because it's 7 wide. If there's an integer value that you're printing, then the .2 will be the minimum number of digits to print of the integer. So really what that means, if you have a number here that is larger than the number of digits that are in the integer, 1, 2, 3, 4, 5, however many you have in the integer, if that number is larger, it will be 0 padded to the left or the right, depending on whether you have used, again, the left justification. If you use the left justification, the integer will be shoved all the way to the left, and the right side of it will be padded out with zeros. If you didn't use the dash, then it will go to the right justification, and it will be padded to the left with zeros to fill out the maximum size of the field. And in this case, this is a 7.2 float. Okay, minimum digits of an integer. Now let's look at all these spec types that are in here. These are the actual conversion characters. A D or an I is a decimal integer. So you're going to print out whatever that value is on the right-hand side of the printf. It's going to be printed in a decimal form with either D or I. If you use O, %O, or % and then dash and the digits O, it will be printed as an octal value, represented as an octal value. X and capital X will print a value in hexadecimal, base 16. A lowercase x will cause the letters of the hexadecimal value to be in lowercase. A capital X will cause them to come out uppercase. A U is used for an unsigned decimal. A C is for a single character. S is for string. We've already seen that. F is for float. We looked at that in the previous one. If you use an E or an uppercase E, that will give you exponential notation with the E plus and the power to raise a number. You can print very small numbers or very large numbers in less space with exponential notation. Lowercase g or uppercase G is to print exponential notation of a double value, which would be a very large and highly precise value, as we saw when we looked at our types, our variable types earlier. A P, that is for a pointer, and that will print out a pointer value. You have to pass an address, is what it expects to see, is an address or the address of a pointer. And that will be implementation dependent. It depends on your compiler, your operating system, your memory type, model, all of that as what that pointer actually looks like. But that's a good way of converting addresses, so it's something you can read. And then we have the double %, which when used in a printf will just give you a % sign. So you have to use 2 percents together if you want to actually print the character % in the printf. So that's what goes into the format string, which is the first variable, the first thing that is passed into printf. And then it takes a unknown variable number of arguments after that format string, and that varies based on what's in the format string. And that's one of our next videos coming up, is how to create your own function that can use a variable length argument list like that. So that's printf, and I want you to see those conversion characters and how to use them, and we will use them quite a bit in the next chapter when we get there and we talk about web programming. We'll use a lot of printf, and we'll use scanf, which is coming up here in a minute. So hang on. Let's take a quick look here at variable length argument lists. You've seen that that's exactly what printf does. Printf takes in multiple arguments, but we never know how many there will be. It depends on what's in that format string as to how many variables are going to be required to fill that thing out. So that gets a little strange to be able to code that and call a function not knowing how many parameters are going to be passed in. First of all, you have to pound include the standard arg.h at the top of your program, and then there's 4 different macros that we use. Those macros, the VA list and start, arg, and end, are all defined in that standard arg.h, the way they actually function inside your particular implementation. The VA list is used to create a special kind of variable, and that's var name. So VA list is just a type like any other, but it creates var name so that it will point to where all these things are located in memory. Then VA start, we pass it the variable that we just created, the var name, and something I called head on here, which is a piece of data that we know is right next to where this parameter list is. And I'll show you that in a sample piece of code here in just a second. Then we use VA arg, and again, that variable list name and the type that we want to get out of there. We have to know what these things are, if they're integers or floats or doubles or whatever. So we have to know what they are so that we know how many bytes of data to read out of this var name list. And that's why printf needs to know if it's a float or a decimal or a string so that it understands how many bytes it needs to read for each of its variables. And then when you're all done, you use the VA end to clean up this special little piece of code that you set out there, this special variable called var name. So let's look at that. I've got a piece of code here called vargs.c. And there we include the standard arg header and the standard IO header. And this is a little function just called average. It's going to take in a number of items to average out, and then it takes the values themselves out here. Okay, so we'll say that there's going to be 5 numbers, and then we actually put the 5 different numbers. Down here, here's how we set it up. We have a double sum. So that's a large floating point, which is going to be all of these added together, and we just have X for a counter. Now here's our VA list, the macro to create the argument list. There's VA list, and arguments is what we call the thing. And here's a VA start. The VA start takes this new type, this new variable, arguments, and num. Num is this guy up here, this integer that came in. VA start uses that to find out where this is in memory, and then create the pointer to the first argument that's right behind that, because these were passed on the stack up here. This ellipsis, this ... tells this function that it's going to be a variable number of arguments coming in, so watch out for them, and that we will have to use VA list and start and so on to read that. So that's a little placeholder right there. That's important to have that there. Now here's our loop, and here we're going to go from 0 to the number of variable arguments that are coming in, and we'll make the sum equal to the existing sum plus the argument itself. And we're going to treat all these as doubles. All these numbers coming in are doubles, so every time we'll pull a double in. Now you can see that printf would have to figure out from the format string how many percent signs there were and know how many items to read and what they each would be if it's going to read an integer or a float or a character or something. This is the kind of place where it does that. And then VA end cleans up the arguments variable that we created up here. And then we just return the sum divided by the number. Now I don't have this initialized right down here because this first value is supposed to be num. 1, 2, 3, 4 numbers, so we'll just put 4 in there. And here we only have 3 variables coming in, so we'll put a 3. That's the way that should be set up. So remember, this one's going to be num, and then how many corresponding to that, how many doubles that we're going to send in. And it's going to add those up and average them out for us. Totally useless, but it shows you how to do the variable argument list. Let's save this, and let's go to our compile window and compile and link it. There we go, and let's run it. There you go. And you can do the math to see if that's right, but I bet it is. So that's all there is to it. That's all it's supposed to print out is our 2 floats. And that's what it did, and that is how to take in variable arguments into your own program. Variable length argument lists.